Okay. So now we're going more in depth into the malware, in this case.
We'll see.
With Mathieu Kazmarek's presentation. Yeah, we're switched. So you have the floor. Thank you.
Thank you. So yeah, first the boring stuff. So I work for Verizon, but I do not speak on the behalf of Verizon. That's not that my team does not support me with this presentation, just legal stuff. But yeah, usual. So yeah, this is not a marketing presentation or anything like that. No sensational attribution or sorry about that. So first, let's have a reminder of what is Regin. There was a couple of articles about this. And basically it is a malware that is used to collect information. And many people make a lot of buzz about this component. You have a launcher, a stager, sometimes a kernel component, and userland component. Well, this is like plugins. You do not care about that. This is just for persistent. This is completely disposable. Stage 1, stage 2, it's just something you can change easily to full AV detection. Then sometimes you have a driver. Why would you like a driver today? Usually it's when you want to hide your communication within a legitimate channel. For example, you have a web server and you want to infect it and to take some part of the communication of the web server. So you will hook the network stack, take some packets that are with a blueprint. And to do that, you need a driver usually. But just for that, back in the days, they always put the driver. Do not always use it, but today, there's a lot. Or I don't know if it's today, but the most recent infection I saw was only userland infection. So do not be afraid by Regin as it's driver, it's complex. No, most of the interesting stuff is there. So on top of that, like plugins or any malware that are really widely used, there are modules so that you can make it evolve or adapt it according to your target. And those modules are stored within some kind of virtual file system. It's just a storage place. Again, it's not something complex. It's just a storage place. So, all right. Just a reminder. So why do I present Regin at botnet, at BotConf? Because it is a botnet. It is not a rat. It is not a usual Trojan with command and control, stuff like that. So if you have IOCs about Regin with IPs, right, just of hardly any use, because Regin is, when you install a Regin node, you configure outbound connections, peers, and there is some kind of routing protocol like BGP that relays the communication over the network, over the botnet, like a peer-to-peer botnet, peer-to-peer botnet. So concerning those connections, you can have anyone. Just need a module for a connection. Can be TCP, can be UDP, can be named pipes, can be cookies, can be files, can be USB keys, can be anything you want. On the other hand, to receive messages, you need to open ports. So you need a module that open a connection or listen to the connection. Not more than that. So this is just for the networking part. But on top of that, you have a trust layer, a trust overlay. And actually, to send packets, message to another node, you need to have a public key, a private key that is trusted, at which the public key is trusted on the other side. So it's pretty common, like SSH servers. You have the private key, you connect to your server because your non-host trusted key, stuff like that. So basically, this is it here. So here, the VPN overlay. Each node has a virtual IP because when you are operating this kind of botnet, you do not care about the actual IP of the infected machine. You just need to have some IDs that you maintain internally. So each node has a virtual IP. And so that you can, for example, root, you're at home. There are a bunch of connections everywhere, but you know that you want to update the filters that collect emails on a server somewhere. You just have the IP of the server somewhere. You send the update, and it will be routed over the botnet to that server. This is how it works. And you have Masternodes. Masternodes is a node that you have at home. That is the node that controls everything. Actually, there are several masternodes. There are two masternodes per victim. And well, let's see that. So this is typically what you have. Victim A that got infected. From victim A, someone infected victim B. And from victim B, you can go to victim C. And you have a masternode that controls everything here. So I've put some XX because you can this is, oh yeah, do not do like my respected antivirus researcher that who is on the virtual IP of the node. This is nonsense. This is a virtual IP. I just put XX just to anonymize stuff because if you are the attacker, you can know which is this victim according to the IP. But this is virtual IP. It's not actual IP. This is, interestingly, this is in Germany, or this was in Germany. This was in Ireland, I believe, and victim C was in Sudan. So you have this kind of network that go about everywhere in the world, and from where you can operate a very big botnet. Very big. This is one victim. When you have a Regin, typical Regin injection looks like that. You have a masternode that have control over everything. Dashed lines are trust. That is, everybody trusts the masternode. The other lines are actual connections. And what you can see is that in that picture, about everyone trusts the masternode, but I do not have any strong line to the masternode. This is because I did not find any actual connection to the masternode. I do not know from where it comes and how to reach it. This is the actual command and control. And this is why IUCs about IP IUCs, domain name IUCs about Regins are really of no use. In this network, you can see particular nodes like this one, this one, this one that seems to collect information from collectors. And this is it. That is, Regin is like a SIM. When you have collectors for events distributed over your network and that are centralized at some point. And actually, those particular nodes are concentrators and exfiltration points. In this infection, there was 8 outbound points. That is, 8 points to go outside that victim. And I believe those exit nodes were actually going to other victims. So to really know where is that command and control, it is very difficult. So I wanted to show that, to try to explain that to you, because in what I saw in public communication about Regin, they explain it just like any Trojan or any remote access tool, and this is really not it. When you deal with Regin, if you ever deal with it, you have to draw this kind of map to hunt for each infected node. Because if you do like the usual stuff, looking for the domain and command and control and blocking the IP, you won't stop the infection. Oh, but how does it work? Because to operate this kind of stuff and to have some kind of reliability over this network, you need a specific design. And this is designed on with a secure service-oriented architecture, SOA, with RPC protocol, remote procedure call. And if you deal with Regin, you know it because of this template. This is an RPC, so it's not IDA yet, but it will come. What is it? RPC. So this is serialized data that you send to this virtual IP. So this is a local IP. It's not a local IP, actually it's a master reporting node, but say 127.0.0.2. This is the module that you want to query, and this is the handler you want to query. So basically, anything you will do with Regin is send remote procedure call to either your local node or to a remote node. And everything is done with modules and handlers. You want to add an IP, you want to add a keyword, you just add a keyword to the module that handle mail interception. This is really how it works. And all the modules, like documented in Simon Tedek and Kaspersky documents, are mostly related to interception and collections of data. And it is pretty easily to write module. And this is what you should do. Because of this complexity, this way of working costs a lot. Because you have the malware, you will do some reverse engineering to know how you are impacted, what information are collected, and then you will write some tools to decode the information with the virtual file system and everything like that. And this takes days to test, to compile, to retest, to review, and you go back to reverse engineering. This way is hard. This way is what I would recommend, because Regin is really well coded on this RPC architecture. And what you just need to do is to get some pointers on those RPC handlers and query the nodes. You want to have the data that is in the virtual file system, just query it. So this is malware instrumentation. And in the paper that submitted to BotConf is explaining the details of the instrumentation, and this is what I want to show you actually. Okay. So typical example. Here, create a stream. I query module 9 under 5 to retrieve the connection list to the peer nodes. And you can do that as long as you have instrumentation of the Regin. So yeah, starting now, you can interrupt me and ask question anytime. No question yet? So, how it works? This is for Paul. So I told you about instrumentation, Regin, the SOA architecture. So basically, the first thing you need to know is the numbers, that module ID and that handler ID. And this is quite easy to spot in Regin because you need to instantiate modules. And this is how you do it. You just do module new with some parameters, with the module ID and the module object. And this pattern is always the same. And it is, you can even write a YARA rule to spot the module definitions. So here we have the definition for module 9 that I will tell you handle everything that is related to network. Then this is not this one yet. Yeah. Then you define handlers, module add handlers, and you have IDs for handlers. So this is how you collect the IDs for handlers. And you have the actual handler, that is this function. Then looking into the function, you will know that the function with the D word, that will be then processed. So you have the actual signature of the handler. So I have the module ID, the handler ID, the parameters I have to send it. I just now need to actually write it. So I take a pointer on module 9, for example. Or what do I do here? No, it's not this one. Here. So let's say I want to query that under 17 of module 9. I know this is an IP, so I parse an IP. I put it in the stream, so write the word, pretty easy, right? And then send the stream to under 9, under 17. And what is interesting is that it actually works. So this is available on the internet. This is a code that does everything I just explained, instrumentation. I load the library of Regin, take a few pointers to the module management and stuff like that, write the codes, and just have a nice interface to query the handler. So if I want to set, for example, net set IP, it won't work. You will see why. Set IP 002. So it's in there first, telling me. So this is actually this. So I just send to module 9. I want to be the virtual IP 0002. And tell me, oh, crypto key is not found. I told you before, you need a private and public key associated to your IP. So I will do that. Crypto key, change IP. IP 0001169 0002169. Success. Okay. Just so I changed my IP. It's not fun. Not yet. No, I told you I have to open port to communicate, to receive data. So net add TCP in port 80. So, let's do netstart first. So netstart, I have nothing. Oh, I've already it open. Net listing. Yeah. So here I can see that module C373 is listening on port 80. And it is actually listening. And you know what? Actually, there is a help. This is all the under-coded, and you can add more if you want. The source code is available on the internet. So, and now for Paul, who told that the demo never worked. Netcons. Here so yeah, maybe you want to. So I configured an outbound connection to node IP 0002 via module C373, that is actually TCP, to that actual IP. This is a real IP. This is the IP of this VM on port 80. And then I will tell you about that one later. So I've configured something, and if I do something like net msg 0002, hello, maybe it will work. Hey! So I just sent a message from here to here. You have to trust me, man. More details. Here, there is something strange. There is a 443. Another thing you need to know with Regin is that there are, when the nodes communicate, there is initialization channel and data channel. The data channel is dynamically initialized on the reception node. That is, if you look here, this one is currently established, but it has been opened on the reception of the initialization message. This is the protocol. The node that sends the message tells the reception node, OK, I will send you data on that channel. So you can, for example, initiate channel with a DNS query and tells, open me a TCP port on 443. This will be opened dynamically and sent to the, and then you will use the data channel to extend channel. So this is also tricky because when you see IOCs and intelligence on Regin, usually they'll talk about the initialization channel, but you also need to look at the data channel if you really want to have the communications. No question?
I saw from your diagram that you have an IP, internal IP of the master node.
Yeah.
And you have a great framework to communicate. Have you tried to communicate with the master node? To send him a LOL, for example?
Oh, well, I only do that on my small laptop.
Ah, I understand. So no live experiments with the Regin.
No real life experiment, we'll say. And about this master node. Because this is interesting. Here. So I told you, I've put XX here too. This is because you have Regin networks are organized on /8 subnetwork, virtual IPs. Always talk about virtual IPs. Do not do who is on those IP. This is stupid. I have to repeat it because people do that. And this is how you can actually identify victims. Because the master node is usually the first IP in the /8 with ending 7 and 8. So, for example, victim 50, the master node of victim 50 will be 50.0.0.7. And there is a second, there are always two master nodes because of redundancy, and the second will be 50.0.0.8. Then you have two master reporting nodes. You do not see master reporting node because master controlling nodes have trust over everything. Master reporting nodes are trusted by no one, but they can receive things from anyone. So they trust everyone. Those master reporting nodes have IP, so for example, 50.0.0.6 and 50.0.0.5, if I remember well. I do not know about 1, 2, and 3, but I believe they are used for specific purpose. Another question? Again, about masternodes, maybe. How much time do I have yet? Okay. Masternodes are really interesting because I told you about those module IDs. Every module I have seen has an odd module ID. But, for example, 9, C373, always odd. But some even module IDs are referenced in the code. And they have a special role because you can, if you have an even module ID, you can send message unsigned, and they are trusted. So I don't know if you're part of a company that do some counterintelligence, you can try to impersonate modules using even module ID and communicate with the masternode. Because to communicate with the masternode, you need to have a private key that is trusted with associated public key that is trusted by the masternode. But if you have even module IDs. And this can be actually spotted in the IDA here. Where is it? 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 Oh, maybe here? Yeah. Continue. Here. This is very particular. When you do some reverse engineering, you will understand why this peculiar compilation pattern. You see here, RBX equals 1, I will tell you that. And to actually set a constant value, you do 1 plus E. Doesn't make sense. Usually you put just F, not 1 plus E. And note that F is odd and E is even. Why? Because the here. This is RBX. It is defined here. I believe that this is a compilation constant, either set at 1 or 0. 0 when you have a masternode, so everything will be compiled with even module IDs with more power that are trusted everywhere, some kind of backdoor. And when you have a slave node that you will put on victim side, you will set the compilation pattern at 1. Know that from what I saw, Regin nodes are compiled a few hours before infection. So this really makes sense. So I did not really experiment with even module IDs, but if somebody wants to do and to try, please. Other stuff? Do I have still time? Yeah. Because I had some spare slides if you do not have any question. Oh.
This flag you mentioned, will it be tested at the source node, at each node in the path to the master node? Because you said you will be able to communicate because you don't need the signing key.
Yeah.
But where is it checked? If it's only at the start node, where you could fake the flag, it's useless.
Actually, so to be precise, so module 9 check that your RPC is signed with RSA public key. And at that access control, there is a whitelist of modules that bypass the signing process. And this whitelist is actually stored on the virtual file system, as argument. And this is what I collected. So you have it on the paper. Where is it? Here. Yeah, exactly. So this is what I collected from different virtual file systems. Those are the module IDs that that I believe bypass the signing verification, and I also spotted where are those module references in the source code, in the binary code. I do not have the source, unfortunately. And 0 seems to be able to manage modules. 4 seems to be able to manage connections. E to edit the cryptographic parameters. Maybe add some private keys. This is why I'm not sure, but it really looks like a backdoor or some kind of hidden stuff by the developer to keep an hand on nodes with some hidden evil stuff. So if you are contracting Regin to do your stuff, I do not know, take a look at that. It's not really sane stuff. Or ask your contractor, why did you put that in the code? Just useless. On the other hand, if you are part of counterintelligence, you can look into that. It might be interesting. Because as far as I know, nobody claimed Regin infection. So I believe first taker, first owner, something like that. Yeah.
Thank you. So I'm Peter Gleisner, working for Looking Glass. I have a question if you can potentially write a crawler to check your local network or even on the internet for region infections. Would that be technically possible?
Yeah, I believe so. I believe you can write some kind of scanner. But writing a scanner, so two questions. Can you actually write it? Yeah, definitely. Just try to communicate. You will see some different pattern in the communication. For example, the packet will be eaten. Like for example, your browser has a blueprint for any channel. And if you put the blueprint, the packet will be eaten and you won't have the return of the HTTP gate, for example. So you can do almost the same with Regin. That is, try to initiate the communication. You will send some packets and it won't have the usual behavior because it will be hidden. This is one way. The second question is, can you do it without being noticed? This is another story. Because, yeah, if you really want to do it seriously, you want to do it without being noticed. So, yeah, you would need to be somewhere on the backbone, send some TCP packets, and we intercept it. So, yeah, it is possible. I did not do that, but it is possible. Another question? So if you want to catch up later at the break, no problem. Now I have 2 minutes left. You want me to, do I have slides left? Defense perspective, yeah. So what do I say that? Yeah, do not use it. Do not, if you use IOCs, be cautious. You need to know how it works before using IOCs because you will have false confidence using IOCs with Regin. Rather use structural detection. So this is what I did in a former position. To detect Regin, I actually used the file structure rather than the file names, for example. Paul has published a way to detect VFS, a script. This is quite cool, and this is the way you should do it. Do the same for network communication. Hunting, yeah, if you want to hunt it, just draw the map and try to go from a node to another node, and so on. Because this is a botnet, this is not usual command and control infrastructure. If you are an attacker, check about those even nodes. This is really strange. Move to hard-coded public keys rather than even numbers. This is just bad. Yeah, watermark in the communication are just useless. Do it after the versified decryption. People who understand that will understand me. Yeah, not interesting. And if you do some counterintelligence stuff, yeah, you can actually, instead of decrypting the traffic from infected nodes, you can actually activate logging on nodes with your associated RPCs. This is much more easier than decrypting, doing PCAPs and decrypting the traffic. Identify adversary intent with the function that are shipped at the nodes. And know that you can always use, for example, the filter keywords. This is, for example, the keywords that are used on the mail servers to filter out mails that won't be processed by Regin. So if you put any one of those keywords in your mail, it will be filtered out and won't be intercepted. On the Regin stuff of iPhone. Yeah, no, this is funny word. This is why I keep that for the last slide. Thank you.